Hello everyone, welcome back to our YouTube channel, and today we are going to discuss lecture number 2 on our topic Fourier transform. As we have discussed already in the previous lecture, we have seen for any function f of x, if we apply the Fourier transformation, this is equivalent to 1 upon under root of 2 pi minus infinity to plus infinity e to the power I s x f of x into dx. और प्रीवियस लेक्चर में हमने दो प्रॉब्लम सॉल्व भी किए थे, जिसमें से एक प्रॉब्लम जो हमारे पास था जहाँ कुछ इस तरीके का ग्राफ इनिशियली हमने कंसिडर किया था, फ्रॉम माइनस ए टू प्लस ए के लिए फंक्शन की वैल्यू यूनिट थी, दैट इज़ 1, एंड ऑन अप्लाइंग द फोरियर ट्रांसफॉर्मेशन हमें सेम फंक्शन के ग्राफ का बिहेवियर साइनोसाइडल फॉर्म में मिला था. नॉट ओनली दिस, अगेन इन द सेकंड प्रॉब्लम वेयर वी कंसिडर अ गॉसियन टाइप ऑफ फंक्शन, ऑन अप्लाइंग द फोरियर ट्रांसफॉर्मेशन हमें वो फंक्शन गॉसियन ही मिला था. सो दिस वेयर द टू स्टैंडर्ड प्रॉब्लम्स जो हमें बेसिकली बहुत सी जगह पे यूज़ होते हैं. नाउ टुडे वी आर गोइंग टू डिस्कस अ वेरी इंपॉर्टेंट टॉपिक दैट इज़ कॉल्ड एज डिरैक डेल्टा फंक्शन. और हम देखेंगे कि डिरैक डेल्टा के ऊपर जब हम फोरियर ट्रांसफॉर्मेशन अप्लाई करते हैं तो इस फंक्शन का बिहेवियर आफ्टर द फोरियर ट्रांसफॉर्मेशन किस तरीके का होगा. नाउ इफ़ आई वांट टू डिफाइन डिरैक डेल्टा फंक्शन, तो डिरैक डेल्टा फंक्शन कुछ इस प्रकार से होता है कि फॉर एग्जांपल अगर मैं x इज इक्वल टू 0 पे डिरैक डेल्टा को डिफाइन करूँ, सो दिस फंक्शन इज 0 एवरीवेयर एक्सेप्ट एट x इज इक्वल टू 0. तो x इज इक्वल टू 0 पे ये फंक्शन एक प्रॉपर पिक देता है हमें. सपोज इफ आई वांट टू डिफाइन this function at any arbitrary point, let us say this point is say x equal to a. So at x is equal to a, this point will have a peak and it will be 0 elsewhere. So Dirac delta function at x is equal to 0 को delta of x कुछ इस तरीके से डिफाइन किया जाता है, and Dirac delta at x is equal to a, this is defined as delta of x minus a. So we will consider one of the function like delta of x minus a को consider करके we will try to apply the Fourier transformation and we will see what kind of behavior this Dirac delta function shows. So we have like, let us define this function f of x, let this function be delta of x minus. So this is defined in the form like it will be infinite at say x is equal to a and it will be 0 otherwise. Means at only x is equal to a this will have an infinite value, और x के अलावा मतलब a के अलावा जो कोई पॉइंट्स रहेंगे that is x not equal to a, this function will have a 0 value. So let us start to find the Fourier transformation. So we have a definition like f of s, this is equivalent to 1 upon under root of 2 pi, then we have minus infinity to प्लस इन्फिनिटी ई पावर आई एस एक्स, और हमारे पास होता है एफ ऑफ एक्स इंटू डी एक्स. सो लेट अस पुट द वैल्यू लाइक 1 अपॉन अंडर रूट ऑफ 2 पाई विल बी देयर. नाउ माइनस इन्फिनिटी टू प्लस इन्फिनिटी, यहाँ पुट करते हैं ई टू द पावर एस एक्स आई ओटा एस एक्स, और एफ ऑफ एक्स की वैल्यू जो हमारे पास है डेल्टा ऑफ एक्स माइनस ए विथ रिस्पेक्ट टू डी एक्स. Now at only x is equal to a, this will have a particular point, उसके अलावा कहीं पे भी फंक्शन डिफाइन नहीं होगा हमारे पास. So at only x is equal to a means we have to substitute the value of x is equal to a, which is by property of Dirac delta function. By property of Dirac delta function. So when I substitute x is equal to a At this, the function will be defined and this will be replaced like the final value will be e to the power sa divided by under root of 2 pi. So this is the Fourier transformation of the Dirac delta function, which is coming out to be e to the power iota sa divided by under root of 2 pi. Now for understanding, this under root of 2 pi is always a normalizing factor. This is always a normalizing factor. So let us consider for our convenience that the Fourier transformation comes out to be of the form e to the power iota sa with under root 1 upon under root of 2 pi as a normalizing factor. So whenever you write down e to the power iota sa, this always represents plane wave. This is representing what? This is representing your plane wave. And plane wave is nothing but combination of cos as well as sine waves. Always a combination of sine wave and cos wave. So from this we are clearly noticing that whenever you consider a Dirac delta function, and then you apply Fourier transformation on it, we are getting what? We are getting plane wave. So this will look like, suppose if this is a Dirac delta function defined at suppose say x is equal to a, then on applying the Fourier transformation we are getting a plane wave which is starting from minus infinity and suppose say ending on what? Plus infinity. So the Fourier transformation of the Dirac delta function will always be a plane wave. Now I hope many of the basic things are clear to you. We will try to solve another problem, which is another important problem and easy also. So let us consider any function f of t which is equal to t and equal to 0. The value is t when mod of t is less than a and mod of t is greater than a. Again, starting the solution, here also you can clearly see for minus a, like suppose if I define this, this will be f of t equal to t for minus a less than t less than plus a, and again this will be 0 when otherwise for other all values the function value will be equal to 0, which is kind of similar to the first problem we have solved in lecture number 1. So on starting, this will be like f of s, I am writing it directly now, this will be 1 upon under root of 2 pi and we have the limits like say minus infinity to plus infinity e to the power I sx, again now f of x into dx. Now remember here the function defined is in the t variable and we have wrote down the definition in the x variable. So let us rewrite this as f of s is equal to 1 upon under root of 2 pi minus infinity to plus infinity e to the power iota st, and now this will be f of t into dt. Clearly you can notice this function is given in the time domain and now we will convert this into a frequency domain. So on substituting the limits, now the limits here are minus a to plus a and it is the function is 0 otherwise. So I can write it down directly like f of s equal to 1 upon under root of 2 pi, limits are minus a to plus a e to the power st into, now for in the limits minus a to plus a, the value of function is t into dt. Now there are number of ways to solve this integration, like you can apply the integration by part, you can apply the successive integration, but if I say this is suppose equation number 1, now we know that e to the power iota st, this can be written as cos st plus iota times sine of st. This is an Euler's identity which is like e to the power iota x is nothing but cos x plus iota times of sine x. So let us put that value. So f of s, this will be equal to 1 upon under root of 2 pi, the limit is minus a to plus a, and cos st plus iota times of sin st into t dt. Now this integration can be splitted into two forms, like 1 upon under root of 2 pi will be constant. Suppose limits are minus a to plus a, this will be like t into cos st plus iota times integration minus a to plus a, again t into sin st dt. So the integration is now splitted into two forms. Now here you can notice that this t is an odd function, cos is an even function. So ultimately this will come out to be again odd function, hence this integration goes to 0, and this will be now f of s equal to 1 upon under root of 2 pi. The first integration will be 0 plus iota times. Now here notice that t is an odd function, sin of st is also an odd function, so odd into odd will be an even function. So ultimately this integration can be written as 2 times of integration 0 to a t times of sin st into dt. So we have to solve this integration now. So on solving this will be simply, again I rewrite this, f of s equal to 1 upon under root of 2 pi 2i times 0 to a, again this is now simply t times of sin st dt. Now we will evaluate this integral and we will reach to the final conclusion. Now here you can apply the successive integration. The successive integration says that for any function u and v, this will be like u is equal to, integration of uv will be equal to u v1 minus u dash of v2, where this v1 is the integration of v function, first integration, v2 will be the second integration, and so on. So let us treat this t as u, let us treat this sin st as v. So f of s will be equal to 2i divided by under root of 2 pi. Now u times, this will be u, the integration of sin st, or rather this is t, the integration of sin st will be minus cos st divided by s minus u dash, that is the derivative of t with respect to t will be 1, and the second integration of cos will be again minus sin st divided by s into s will be s square, and your limits are from 0 to a. Here clearly you can see this minus sign comes because this cos st is having a minus sign with itself. So this will be 2i divided by under root of 2 pi, this integration, this bracket, this will be minus t times cos st divided by s, minus minus this will be plus, again sin st divided by s square, and our limits are from 0 to a. Now let us substitute the limits. So we will substitute the upper limits. So this will be 2i divided by under root of 2 pi. Now on substituting the upper limit, this will be minus a, this will be cos sa divided by s plus sin sa divided by s square. These are upper limits. Now minus the lower limits. Now here lower limit is 0. So if you put 0 in the place of t, this will be already 0. And again if you put 0 here, so sin 0 will again be what? This will be again 0. So ultimately your lower limits contributes as 0 only. So this will be 2i divided by under root of 2 pi. And let us rearrange this. Rearrange in the form like, let us write it down like sin sa divided by s square and minus a cos sa upon s. Now this can be ultimately written as twice I divided by under root of 2 pi integration of sin sa upon s square minus, suppose say as cos sa divided by again s square. So we can take 1 upon s square as common. So this will be 2i divided by under root of 2 pi into 1 upon s square, and your solution will look like sin sa minus as cos of sa. Will be your Fourier transformation of the given function. And I hope you people are liking the lectures. Do like, comment and subscribe.